So, as I mentioned, the self-identifying nature, I guess, or features of the D-Series amplifiers, let's see it in action here as we set up an AcqKnowledge file. So we'll open up AcqKnowledge. And here we obviously have a number of different options, but we want to, in this case, create and record a new experiment. So with that button already selected, we will hit OK. And because we have the D-Series amplifiers already plugged in and connected, when the menu initially comes up just like this, you can see exactly what is plugged in to the AMI 100D MP160 system and what is ready to record. So on channel 1 we have the ECG 100D. On channel 2 we have the EMG 100D. On channel 3 we have the PPG 100D. Channel 4 is respiration, and channel 5 is an EEG 100D. So obviously we have up to 16 channels available and could have 16 D-Series amplifiers plugged in, or for that matter we can have any combination of D-Series, C-Series, or even wireless BioNomadix transmitters plugged in. So it's any combination, but obviously in this case we're focusing on D-Series. And with this, I mean, it's long and short, it's that easy. If we had a subject currently connected with leads on, and the respiration strap and everything like that, we could literally close out of this menu, hit the start button, and immediately be collecting data. So it just minimizes the front end of system setup and makes it 100% plug and play. Now, there are some additional things that we can do with each amplifier if we want to. As of right now, you can see, I'll go into the calculation tab, and we have 0 calculation channels set up. And anything set up here within this calculation tab is going to be done in real time. So we'll see those calculations occurring and being calculated as we're collecting data. So if I go back into the Smart Amps tab, for instance, and click on the little arrow next to ECG, it will break out a couple of options that we can either select or not select. It's up to us. So number 1, by default the ECG, the amplifier or the filter settings are set from 5 to 35 Hertz. So we generally want a nice narrow bandwidth just to minimize ECG or to minimize motion artifact and really maximize and get a nice clear R wave to basically cue off of for the heart rate and or heart rate variability calculations. So I would say the vast majority of people would never use the wideband. There'd really be no reason to use the wideband, so we'll keep that unselected at this point. But a lot of people do want to see the heart rate being calculated in real time, and if that's what you want to do, you simply check that button. And once we check that, if we go back over into the calculation tab, you'll now see that heart rate will be calculated as we're collecting data. So that'll be an additional channel that we'll see. Go back to Smart Amps. At this point, I don't need to see the R to R interval or the R wave amplitude, so I can close that one down. Under EMG, again, we've got a couple of options. We can either go wideband, so by default EMG is 10 Hertz to 500 Hertz, and wideband is 5 Hertz to 500 Hertz. If we want to, we can show either the integrated or the root mean square. And if I select integrated, and then again go back to my calculation tab, I can now see that I've got that calculation already plugged in automatically. And so that's kind of what you can do with stepping through these. So with the pulse, we have the option of calculating the pulse rate, which would be similar obviously to calculating the heart rate. So if we'd want to compare the two, we could do that. With respiration, generally people are interested in seeing the respiration rate. So of course we can do that either with normal breathing, or if we have somebody exercising to where they're going to be breathing at greater than 20 breaths per minute, we would choose this one. For now, we'll just choose that. And then for EEG, here we can select which bands we want to break out. So we can break out alpha, beta, delta, theta, or gamma. If we're interested in calculating gamma, we would need to go into wideband mode, because otherwise the default bandwidth is I believe 0.5 to 35 Hertz, and that's not going to capture gamma. So if you are interested in capturing gamma or breaking out gamma from the raw EEG, you would need to go into wideband mode. But here, if we wanted to, let's say we want to calculate alpha, beta, and delta. Close that down. Go back into our calculation channels. And you can see that just like that, all those are ready to go. And with that, we're basically ready to collect data. So if I would close out of here, we are now good to go just by simply hitting the start button. Okay, so once again we will launch AcqKnowledge, and again we want to create and record a new experiment, in this case, to set up a new graph template file. So we'll hit OK. And we are immediately greeted with this window. And I do want to say that those who are running previous versions of the software earlier than, I believe, 5.0.6 will not have this Smart Amps tab. So you'll be looking at the analog, digital, and calculation tabs, but the Smart Amp tab is specific to the newer versions of software, I believe starting with 5.0.6. So we're going to go to, again, the analog tab, because again we're going to be setting up C-Series amplifiers, and we want to add a new module. So by clicking that, we get a drop-down list of an alphabetical drop-down list of every possible module or amplifier that can be connected to the MP160 system and obviously used for data acquisition. So let's just set up a few. Let's start with ECG 100C. And so whether you're doing the ECG 100C or the ECG 100C-MRI, which is specific for those collecting ECG data within an MRI environment, you would use this this line right here. We'll click that, hit add, and as seen when we were walking through the hardware, on the top of each amplifier is the channel selector switch, and so we'll want to make sure that this matches the selector switch on top of the amplifier that we're setting up. So in this case, I'm going to leave my ECG amplifier on channel 1, hit OK. And a question that comes up a lot, which I mentioned a little bit earlier, is what should be the default settings for each amplifier? And I would say 9 times out of 10, you can generally go with this setting here. So, the buttons on the amplifiers, the different dip switches on the amplifiers, those can get shifted during shipping or things like that, even within the lab setting, depending on where the system is located. It's not unheard of for someone to touch things and change a switch or something like that. So it's generally best, I think, to cue off of this and to make sure that the front of the amplifier matches this as opposed to this matching the front of the amplifier. I say that, but then there's always the caveat that I always add in, that it's also, as a researcher, your responsibility to be reviewing, the literature that applies to your specific, research and application. And if different settings are needed, for any specific signal, that's where you're going to have to defer to that and set the amplifiers up accordingly. But again, for the vast majority of people, I think that the default settings that we have within the software are going to hold and be good. So let's click OK there. And just like that, the ECG is set up. We can label it, and then we can add another module. So let's go down and add respiration. That's the RSP100C. We'll click Add. We'll put the selector switch on that amplifier, channel 2. Hit OK. We'll confirm that these settings here, that we match the settings on the amplifier to these settings here. Let's add another one. Let's do EDA, as that's a very common one. We'll click on Add. We'll put that one on channel 3. These settings are good, and I do want to note that it is quite important that both high-pass filters are set to and remain on DC. It would be a quite rare instance to where somebody does not want to record EDA in full DC mode, so it's best to always leave these in full DC, as if a and that way, if a high-pass filter is needed for any reason, it'll be calculated in the software. But if you have this on, there's no going back, so it's always best to leave these in full DC mode. Click OK. And with the EDA, it does run an initial calibration, so at this point you want to make sure that the EDA is connected and everything, but that the leads are not connected to the subject at this point in time. So we can hit calibrate, and then we can go, and then we can hit continue. So that's basically how you set up, NEC series amplifiers, is just by basically clicking the Add New Module, finding it on the drop-down list, adding it, making sure it's on a unique channel, and making sure that the settings in the software, or that the settings on the amplifier match the settings in the software. Again, that's probably going to hold true for 90% of the cases out there. If we click on the View by Channels mode, this just gives us another look at the channels that we currently have, that we're currently set to record from. So again, ECG, respiration, EDA in this case. And it also shows us the sampling rate, which right now by default we're set to sample every signal at 2,000 samples per second. And that gross overall sampling rate is set over here under the length rate option. And as you can see, we're currently set to sample at 2,000 samples per second. So if I click on this drop down box, this allows me to choose my overall sampling rate to apply to all channels, and it can range from, all the way down from 0.1 samples per second all the way up to 200,000 samples per second, crazy fast. So, the vast majority of people are probably collecting between 1,000 and 5,000. And then, for certain instances, probably most commonly for those within an MRI type setting, at that point, a lot of times we do recommend oversampling, and so a lot of times we're encouraging sampling rates as high as 20,000. But again, those, those instances are farther and fewer between. So we'll leave it at 2000 in this case, and we'll go back into our channels. And I just want to point out that although right here, because we have this set at 2000 samples per second, all channels by default are set at 2000 samples per second. But we can go into each individual channel and we can downsample it in real time if we want to. So for example, if obviously respiration would never need to be sampled at 2000 samples per second, so we can bring that all the way down to let's just say 62.5. And for the most part, EDA would never need to be sampled that fast. I have heard that more and more people are looking to delve into like the higher frequencies, or try to extract the higher frequencies within the EDA, and so sometimes 1000 samples per second is being used in a few more cases now. But historically, and probably for the vast majority of users, collecting at 62.5, even 31.25 is absolutely plenty. But again, I say that, and then I always add the caveat of you've got to also refer to the literature that applies to you specifically. So right now we're set to collect these 3 raw signals, and if we want to do calculations from these, we can do so either online or offline, after data is collected. If we want to set up calculation channels that we want to see in real time as the data is being collected, we want to set up those under this calculation tab here. And to do that, we simply turn one of the channels on by clicking acquire. We will click the preset drop down, which again brings down a menu that we can choose a number of different calculations from. For the a lot can be done within here, and we definitely don't have time to go through all the different things that are in here. It can get extremely detailed. Again, AcqKnowledge is a very powerful tool, and you can do a lot of calculations within it if you want to. In this case, we're going to do some fairly simple ones, such as simply calculating the ECG, the heart rate from the ECG. And that's a preset, so we've got that in this preset menu down here. So if I click on that, my source channel, I want to make sure that I'm calculating from the right channel, that I'm using the correct channel to calculate the right information. So obviously we want to use the ECG channel to calculate the heart rate, and we want to calculate the respiration rate from the respiration channel. And I'll add my value here. And so now when we start collecting data, not only will we see the 3 raw channels of our ECG, respiration, and EDA, but we'll also see the heart rate and the respiration rate being calculated in real time. And again, if you don't need this data in real time, it can be calculated after the fact, so you don't need to worry about it if for some reason you forgot to set these up. But again, anything that's set up here under this tab is going to be seen in real time, and that can be a benefit obviously in certain cases. Now to save this as a template, so that we don't have to go through this process every time we come into the lab and turn the system on, we want to go down to our options down here, and we want to save it as a graph template. And so here I can just name this whatever I want to. It's going to be saved as a .gtl. I'll just save that for now to my desktop so I can find it real quickly. And let's just close out of here quickly. And I want to close out of here as well and get back to our main menu. So this is again what you see when you first launch AcqKnowledge. So with that template created, you could actually see it right here, sample1.gtl. So now when I come into the lab, I do still want to record a new experiment. But I'm going to use my template to do it. So I'm going to select this radio button. So instead of creating an empty graph, I'm going to use a recent graph template. Click on my GTL. And if I go to my MP160 Setup Data Acquisition menu, sure enough, you'll see that I've got my ECG, respiration, EDA all ready to go. My sampling rates are all set as I set them up. They're all held in place. And my calculation channels are ready to go. So at this point, again, I can close out of here, and with my subject connected, I can simply hit the start button and start collecting my data. Alright, so lastly here, as a final step to covering the BioNomadix modules setup, we want to go into AcqKnowledge and get things set up from a software perspective. So let's open up our AcqKnowledge software. And again, in this instance, we want to create and record a new experiment. So hit OK. Alright, and so this pops us up. Again, consider right now the software is basically a blank slate. And so we are needing to tell the software what hardware we're going to be working with. And again, in this case, we're going to be working with the wireless BioNomadix units, and it's basically very similar, or kind of the exact same setup as working with the C-Series amplifiers. So you're greeted with an alphabetical drop-down list of basically every amplifier or potential module that could be plugged in and utilized with the MP160 or MP150 system. So it's just a matter of scrolling down and finding the modules that you're going to be utilizing. So in this case, let's just say we're going to be using, let's go down and do respiration and ECG. So let's scroll down here and we will find the RSPEC-R, and again, this is going to match the wording or the labeling on the amplifier itself, or on the receiver itself. So we will add that. And now this is where we're greeted with, this basically provides a schematic of the front of the receiver. And this is where it can get, I guess, a little confusing if you haven't set it up before. Because again, each receiver transmitter pair is a two-channel system. So again, with this one transmitter and receiver, we're going to be potentially collecting respiration and ECG at the same time. We don't necessarily need to, though. We can do just respiration or just ECG, or of course both of them. So the best place to start actually is down here at this level. And if we want to collect both respiration and ECG, the first step is making sure that both of them are turned on. If for some reason you're only collecting one of the variables, then of course you would disable it and just turn that channel off and not worry about anything else. But in this instance, we want to collect both of them, so both will be on. And then this switch, the choice here between X and Y determines ultimately which channel the data is going to be collected on. So for respiration, for instance, if I have the X bank checked, I can choose to record the respiration signal on it's either going to come in on channel 1, well, if I'm on the X bank, it's going to come in on channel 1, 2, 3, or 4, or if I switch to the Y bank, I can collect it on channels 5, 6, 7, or 8. For now, let's leave it on channel X, and we'll put it on channel 1. For ECG, the same thing. I'm actually going to flip it to channel X, and now I can choose to record it on either channel 9, 10, 11, and 12. Or of course, if I put it on bank Y, I can now record that signal on channel 12, 14, 15, or 16. And the reason we do that is, again, you can have up to 8 BioNomadix receivers on one MP system. And so with a combination of the different banks and channels, of course, we can put each one on a distinct channel ranging from channel 1 all the way up to channel 16. So with that in place, we simply hit OK. This is just a reminder. It's obviously at this point, it's the software is just thinking that we're setting this up in order to collect data. Once we get everything set up, so it's just reminding you to make sure that the transmitter is turned on. So we just hit OK, and now we'll see this up here. Now if we want to add a new module, just click Add New Module, and let's say we want to do just a couple channel, or let's do actually EDA and Pulse. So we'll go down to the PPG ED right there. We'll hit Add, and again, now we already have two the respiration and the ECG hooked up, and that's going to come in on channels 1 and 9. So we need to change both of these. So the PPG is on. We're happy with that. We'll keep that on bank X, and we'll change that to channel 2. And then for the EDA, that's also on. We'll change that to X, and we'll put that on channel 10. Hit OK. Again, we're prompted to ensure that the transmitter is turned on. And in this case, with the EDA, it does do an initial calibration at this point. So generally right now, you'd want that transmitter on with the leads plugged in, but not connected to the subject. And at that point, we're going to want to calibrate. We hit Calibrate, and then now we're free to connect everything to the subject and hit Continue. So in this instance, like I said, right now we're ready to collect data. We're ready to collect ECG, respiration, pulse, and electrodermal activity. We can, if we want to view by channels, we can click on this button down here, and it shows us specifically what channels we're using. So obviously respiration is on channel 1, PPG is on channel 2, ECG is on channel 9, and EDA is on channel 10. And that's a nice visual check just to ensure, again, that we don't have any channel contentions, because we do not want to be recording two channels on the same, or two signals on the same channel. So if I go back to my view by modules, there are a couple options, and this one here, basically, you remember when we first added the amplifier, it gives us that prompt to ensure that the transmitter is on. If you don't want to see that every time you hit the start button to collect data, you can disable that by unchecking those boxes. And then this one here is, you can either check or uncheck it on whether or not you want to include the module's channels in the initial values. So with those set, the only other thing that we might want to do is potentially set up calculation channels. And again, if we want to do any calculations in real time, we would utilize the calculation channels under this menu. If real-time calculations are not necessary, then you can basically just not set this up here, and you can do it after the fact under either the transform or the analysis menus within AcqKnowledge. But for instance, if we do want to set up a couple calculation channels, we just hit the Acquire button, click the drop-down menu, and again, this can be kind of overwhelming at first because there is a lot that you can do with the calculation channels. I mean, you can get very, very detailed and write expressions and functions. You can create meta channels to where you're doing calculation on top of another calculation, and so on and so forth. So there's a lot you can do here. To be honest, so the vast majority of people are doing, the simpler side of things, and in this case, that's what we're doing. A simple, let's calculate the heart rate from the ECG data. So we're just going to go down to one of the presets. We'll do heart rate right here from ECG. And the only other thing to change is the source channel, because obviously we don't want to record heart rate and have that calculated from the respiration channel. So we need to direct it to the ECG channel, which in this case is channel 9. And then we can hit OK. And I'll click value there as well. That's also an option. Let's do one other one. So we're going to click on acquire, go to the drop down menu, and in this case let's do the respiration rate. So respiration rate, and in this case we're currently on the respiration channel, which is channel 1, so there's nothing actually to change there. We can click OK, hit values. And you don't necessarily need to hit values, but what that allows you to do is as data is coming in and as the heart rate and respiration rate are being calculated, if you want to see those values in real time or even in like a bar chart format, this enables you to do that. So it's kind of nice. And with that, we're basically set up. It's just a matter of, at this point, closing out of this menu, obviously making sure that the subject is properly hooked up to the necessary transducers and electrodes, and hitting the start button.